Hi everyone, welcome back to College Algebra. So in the previous lecture, I talked about exponential function, and we also talk about domain and range of exponential function. We talk about the application of exponential function, and I remember that I give you the graph. That graph belongs to the standard form of exponential function, something that look like this, right? Recall. So I give you these two graphs. One of them is like this, and the other one it look like that. One is increasing, the other one is decreasing. Okay. And I also say that the x-axis here become the horizontal asymptote. You see that the curve it never crossed the horizontal asymptote. However, we have a lot of exponential function where the horizontal asymptote is not the x-axis. It could be something like this. The horizontal asymptote become the horizontal line y equal to -2, for example. And we have the curve that look like this. And when we have this case, you see that that curve here intersects the x-axis at one point. This point right here. Okay. This point we already learned is called x-intercept point. You know, remember when we have a linear function, linear curve, and that the line intersect the x-axis at one point, we call the x-intercept point. So over here, this point is also called x-intercept point. And because this point is the x-intercept point, when you find x-intercept point, what you do? You set f of x, right? You set y equal to 0 and you solve for x, right? Those answer, if you write those answer in the order pair form, we call the x-intercept point, right? So it means what? It means that if we can set the exponential function equal to 0, then we can solve for x-intercept point. It means that we can solve exponential equation. Okay? So this is like any other equation. Exponential equation is just an equation that contains exponent. Okay? Contain exponent. And the solution of exponential equation is actually the intersection point between the curve, okay, exponential curve, and the x-axis. Okay? And we have two methods to solve exponential equation. So today, I want to talk about exponential equation. How we solve exponential equation. And we have two methods. There are two methods to solve exponential equation. Okay, two methods. The first method, we use a property called equivalence property. Equivalence property. The second method, we use another new function. It's called logarithm. Logarithm function. Logarithm function. Yes. Logarithm function, I haven't talked to you about that yet, so I will. So as long as we learn logarithm function, that is the last function in college algebra level. We will come back and use logarithm function to solve exponential equation. Okay, so in this video, I just talked about equivalence property only, the first method. Okay, equivalence property. Okay, what is equivalence property? Hopefully that you guys already reviewed on the exponential formula I told you to do in the last video. That's very helpful. It helps you to solve exponential equation. The equivalent property state that as long as you have the same base on both sides of exponential equation, then you can set all the exponent together to solve for x. Okay? So the goal is to get the same base. If you don't have the same base, then you cannot solve exponential equation. Okay? So this is the equivalence property about. Okay? If b, x, y are real number, okay, are real numbers, of course b must be greater than 0 and b is different from 1, then b to the x equal to b to the y is equivalent to x equal y. Okay, how we understand this property? So you see that b to the x is a power number. B to the y is also another power number. This power number equal to this power number. That's what it said. And because the base is the same, so I can set the exponent x and y here equal each other. Example, if I have something like this. Okay. Solving the following equation. I'm going to give you something simple. If I have 2 to the x, okay, this is a power number, right, equal to 2 to the third power. Okay, so you say we have 2 power number and the base is 2, then I can set up the exponent equal to this. So this implies x equal 3. There you go. Then we successfully solved for x already. Okay, this is very simple exponential equation. I think this is the simplest one. Okay, I can give you something harder. Okay. For example, like this. I have 3 2x minus 6, 3 to the 2x minus 6, okay, equal 81. Alright. This is exponential function because we have exponent, we have the base. Okay, the exponent for this power number is 2x minus 6. This is just a number. Then how we do this? The goal is to get the same base. Right now, on the left hand side, base 3, which is good. Okay? But 81 is like 81 to the first power, you know. 81 is the base. It's not the same as 3. So we need to convert. We need to bring some way, somehow. We need to manipulate some way, somehow, so that the base is the same. Of course, you cannot convert 3 to 81. You know, the small number to the big number is hard. But yeah, I can convert 81 to something with base 3. So on the left hand side, I keep 81 is actually 3 to the 4 power. Right? 3 to the 4 power. See, right now I convert 81 to the power number 3 to the 4 power, and now we have the same base. And because we have the same base, I can apply the equivalence property. I can set up the exponent of each power number equal to each other. Okay, so what we have here? We have what? Okay. And we'll have what? So on the left hand side, the exponent is 2x minus 6. So I set up 2x minus 6. Oh, sorry. 2x minus 6. Okay, that's the exponent. Equal to 4. 4 is the exponent of this power number. So 4. Okay. And now I have 2x equal to 10 and x equal to 5 easily. Here you go. I already got the solution for this exponential equation. Okay. But this is still kind of simple. Okay. It's still kind of simple. Let me give you something else. So this is A. This is B. C. So remember, the goal is still that bringing to the same base. If you don't have the same base, you cannot do it. Okay? If you don't have the same base, okay, that is where the second method jump into place. You have to use the logarithm function. But right now, we haven't learned that one yet. Okay, we're gonna talk about that. We're gonna do example using logarithm function where we have different base. Okay, when we have the problem that you cannot change to the same base, then you must use logarithm function. But right now I'm going to give you the problem that, of course, that you will be able to change to the same base. Then you should. Okay, 25 4 minus t. Okay, so we have 25 is the base, 4 minus t is the exponent, equal to 1 over 5, ooh, we have fraction, okay, to the 3t plus 1. Okay. So we need to solve for t. Over here we solve for x, but that's okay. It's just the variable, you know, it doesn't matter. This is a little bit harder because you see that we have the base over here 25, you have the base over here is 1 over 5. We have two different base, same thing over here. But for this one, 81 you can change right away. I mean, if you're good, okay, you can see. And for solving an exponential equation, you must be able to see. Okay. How we're gonna bring 25 and 1 over 5 to something so that we have the same base? That will be the big problem, right? But if you recognize this, okay, you will see that 25 is 5 squared. It looks like I can bring it to that base. So 5 squared, okay, to 4 minus t. 1 over 5, you can change it into 5 to the negative 1. So remember the exponential formula we learned in intermediate algebra. Remember we have 1 over x to the n is the same thing as x to the negative n. If you can change the sign of the exponent by flip it between the numerator and denominator. Remember this formula? Intermediate algebra level? Okay. That's why I want you to review. Okay. So over here 1 over 5. 5 is the same as 5 to the 1, right? So I flip them up, it becomes 5 to the negative 1. And I apply this formula, x to the m raised to the n equal to x to the m times n. We already learned this intermediate algebra level also. So this is give you what? Give you 5, 2 times 4 minus t. Remember, when you multiply by the difference or the sum, you have to put parentheses. Same thing over here. 5 negative 1 times 3t plus 1. So now what we have? We have two power number. The base is 5, same base. And now I can apply the equivalence property, the base is the same. I can set the exponent together, equal to 4 minus t equal to -1, 3t plus 1. And now this equation is very simple. Everybody should be able to do this. If you don't know how to do this, okay, please, okay. This is a two-step equation. After you have parentheses, you distribute it, right? I give you 8 minus 2t equal to -3t minus 1, and give you t, okay, give you -9. So t equal to -9. T equal to -9. And it's good if you have to go back and check it. You can put -9 here, okay. You have calculator, so that is the step you have to do. So on the test, because sometimes you have the solution, but you have the solution, but that solution does not satisfy the equation. So make sure that you have to bring it back to the original, plug t back as -9 into the equation to check if it is satisfy the equation. If it satisfies the equation, then that will be the solution. For example, over here, you plug 3 in here. Okay, 2 to the third power is 2 to the third power. You plug the equation over here, x to the 5th, x equals 5, so plug 5 over here. 5 times 2 is 10, 10 minus 6 is 4. Okay, 3 to the 4 is 81. The same. So you have to check. Okay, you have to check. Alright. I can give you another example. Okay. Give you another example. So I'm going from the easiest one to the hardest one. Okay, but you see that the general strategy is the same. You still have to bring it to the same same exponent, same base. Okay. Let me see if I can find something on the internet here. Okay. Some problem is very interesting, you know. So many exponential equation is very interesting, you know, because I remember I learned this when I was in I think 11th grade, and I thought it was very interesting. Okay. Now how about this? Let's do this. Okay, example 2, you have 2x squared minus x plus 8 equal to 4 raised to the 1 minus 3x. Oh, you have base 2, you have base 4. You can convert this to base 2 easily, right? Because 4 is 2 squared. Okay, it's kind of easy too, so I rewrite it. X squared minus x plus 8. 4 is 2 squared. Okay. Alright, now we have the same base. Because we have the same base, you can set the exponent together. The exponent over here is x squared minus x plus 8. The exponent over here is 2, 1 minus 3x. So look like we have a quadratic equation, and every time we have quadratic equation, we have to factor, right? But before doing that, we have to distribute. Okay. And bring it back here. 5x plus 6 equal to 0. Now you just go have factor. Okay. X 3, 2 equal to 0. And you can solve x equal to -3, x equal to -2. Again, you have to go back and check, because you have two solutions. We have to see like both of them satisfy or not, or just one of them. And to plug them back in here to see. Okay, I think it works. -3, -10. Now it's 10, 4 to the 10. -3 here, 9. 9 plus number 3 is 12, 20, 10, 4, 2 is 20. Yeah, it worked. Okay. Alright. Okay, make sure you check this too. Okay, I'm not gonna go ahead and spend time checking both of them, but on the text you have to check. Alright, example number 3. In the example, I want you to practice yourself, okay? I thought it's very interesting problem also. 5x to the 1 minus 5 to the x, okay, equal to 2x to x plus 1 plus 2 to the x plus 3. So this is the hardest equation and I want you to try yourself. Remember, you have to bring it to the same base, okay? And it must be in the form b to the x equal to b to the y. It must be in that form. You see, this is not in that form yet because you have too many terms here. You see, this is already in that form. This is already in that form. You just need to change a bit, okay? But this is not in the form b to the x equal to b to the y. So you need to manipulate more than what I have over here, okay? So go ahead, try this. Hopefully you get this. In the next video, I will try to solve this problem for you. So have fun with this one, okay? And that's all for the lecture of solving exponential equation. In the next video, I will be talking about the last function, logarithm function. Then we will be able to learn the second method to solve exponential function, exponential equation. Thank you so much. Bye bye.